My name is Alena, and I work as our Science on a Sphere presenter here at the MSU Museum. And the MSU Museum is a science and culture museum, and today we're going to be focusing on the science of it with our trusty Science on a Sphere exhibit. And we also have Nick Van Acker on our Zoom call, so he is my fellow Science on a Sphere person here at the museum. And we are we're in different locations, and so we are following all of the university guidelines for preventing the spread of the coronavirus. Okay. So today we're going to be looking at a bunch of really cool animals down in the deep and how we discovered their existence. So, speak more slowly, please. I can do that. Thank you. Yeah. Okay. We can get started with the program? Sure. Okay. So, over here we have our first data set. I'll let it adjust. And it's spinning. Okay. So in this image, we can see the sea floor. It's full of mountains and valleys and ridges, just like the Earth's surface above the sea level, but it wasn't quite as easy to figure out what was going on under the ocean. We didn't have a good map of the seafloor until 1977, the same year that the submarine Alvin discovered something brand new down there. Alvin was a submersible that could carry a pilot and 2 scientists to about 4,500 meters or 2.7 miles below the surface. In 1977, geologists used Alvin to examine volcanic areas and areas along the mid-oceanic ridge where they believed new seafloor was being created. Let's add some triangles on here. So I just added a couple of green triangles. Not sure if you can see them that well due to the lighting. But these triangles represent more than 1,500 known volcanoes that are on the surface. So if you notice any patterns in the locations of these volcanoes, you can put that answer in the chat. Let it spin a little bit. Anything? Might be kind of hard to see.
Yeah, can you repeat the question, Alena?
Yes, so the question was, do you notice any patterns in the locations of these green triangles of the volcanoes? Rotating.
Yeah, and they're a little hard to see on there, but you'll be able to see. Maybe if you want to flick them back and forth, you can make them appear and disappear and kind of flash them so people are able to see them a little bit better. Or you can zoom in. That's perfect too.
There we go. So they're right along the edges of the continents for the most part, and in these areas where we have ridges on the seafloor. Cool, they can see them. There we go. Yep. So the geologists back in 1977 noticed the same pattern, and they used that and other information to decide where to look for underwater volcanic activity. So for more than 5 years, a team of marine geologists and geochemists have been searching deep sea plate boundaries for possible hydrothermal vents. So the Earth's crust is made up of all these different tectonic plates. And I just added some lines on here which represent the different plate boundaries. So these plates are moving together, they're moving apart, they're kind of going under each other. And as that's happening, we have different things going on. So they're looking at these boundaries that we have represented by the green, purple, and red lines. So they're using the latest in technology to look for warm water areas coming up from the seafloor. And for a while, they were measuring the water temperature and taking pictures of this dark and barren seafloor. It looked like a desert, but underwater. But after a while, they found spikes in water temperature. And that was this area. Let me get stop spinning. Right off the coast of South America. And it will stop spinning eventually. Yeah, okay, there we go. So, right in here, right off the coast of South America near the Galapagos Islands, in an area that is now called the Galapagos Rift. So let's dive down and look at what they saw. Diving down to about 2,500 meters or 1.5 miles below the surface. So when they were going down, there was a team of geologists, right, and geochemists, and they were looking for stuff like this rock, volcanic rock. But what they found was actually a lot of life. So like these giant clams or these giant worms that were about as long as their arm. So they called them riftia worms after the rift that they found them in. And then in 2011, they brought some biologists back with them to look at the animal life that they saw there, and they got this really cool footage of the riftia worms as they were spawning, and then just zooming in on them. You can see all this stuff floating in the water. And then in these images, we can actually see really well their red plumes here. So the riftia worms use these plumes to filter out nutrients and chemicals from the seawater, and they use those chemicals and nutrients to feed the bacteria that live inside them, and then the riftia worms get their energy from those bacteria. All right, let's head back up to the surface so that we know a little bit better. So in this data set, we're looking at the different vegetation and algae on the surface of the world. And all of these different plants and algae and phytoplankton, they all depend on the same process to convert sunlight into energy. What is that process called? Put it in the chat. The process that turns sunlight into energy. Photosynthesis, yes, that is correct. So all of these plants on the surface, they use photosynthesis. They depend on the sun for their nutrients, for their energy. But I'll bring up another data set. And the sphere did not just break. Our data set is completely black. So this is what it looks like down on where those rifts and hydrothermal vents are located. The sunlight doesn't reach down there. But we still had all of those organisms that were surviving and thriving. So you can think about how are these organisms surviving without sunlight? And we can just think about that as we move through the next couple data sets. So since 1977, well, we're going really fast. Why is it? Let's try this again. Okay, so this data set shows all little red stars represent vents that we've discovered since 1977, and there are about 200 of them so far. So they'll just keep popping up. We're in about the 1990s now. And we'll let it go. This data set runs until 2011, so it's not totally recent. There have been some vents discovered since then, but we got most of them on here. Okay, so this is 2011. Does anybody have any guesses as to what region of the world we're looking at right now without any reference points? Looking at the distribution of the little stars here. Get this. So we're looking at a region of the world that on land is called the Ring of Fire. And let's see. Yeah, so this region over here. So above land, there around the Pacific Ocean, there's this ring of fire of volcanoes. And the same thing occurs with these hydrothermal vents underwater. So we have an underwater ring of fire and an above water ring of fire. Okay, so let's talk about how hydrothermal vents actually work. Bring up this diagram. Stop it spinning. Okay, here we go. And I'll zoom in. So the water down at the bottom of the ocean is very cold, but when it hits these, there are some spots on the seafloor where we have this magma that's kind of close to the surface, right? So the water kind of percolates down into the seafloor. And as it hits these warmer areas, this super hot area, it warms up, the water warms up. and then it gets pushed up since the hotter water is less dense than the cold water. It moves up, and it gets shot out of the top of this hydrothermal vent at a temperature of about 350 degrees Celsius, or about 662 degrees Fahrenheit, which is very hot. The boiling point of water is 100 degrees Celsius, or 212 degrees Fahrenheit. So if we weren't so deep underwater with all this pressure, this would definitely just be steam. So when it comes up from the seafloor, moving through all these rocks, it brings up with it minerals and chemicals that it expels through this hydrothermal vent. Let's look at another location of a hydrothermal vent. This one is called the Mid-Cayman Rise and is located in the Caribbean. We'll dive down to about 2,300 meters or 1.43 miles. Here, we have a remote operated vehicle looking at this hydrothermal vent area. And if we zoom in a little bit, give it a moment, we can see all of these shrimp that are living on the vent. And where's okay. So the hydrothermal vents, they might not have a huge diversity of species like maybe a tropical rainforest does above water, but they do have a lot of the species that exist there. So here we have so many, like hundreds of shrimp that are living here. And these shrimp are all jostling for the best location for the food, for the bacteria that they depend on. Here's the shrimp, a couple fish in there, but mostly shrimp at this location. And then, so the scientists decided that they would put a temperature probe down in the water here. And we're looking at it to see how hot it was where these shrimp were located. So it was about 600 degrees Fahrenheit, right at the edge of the hydrothermal vent, right? But here it's only about 40 degrees Celsius. So it's, at this point, the water has mixed together. So if we see, yeah, so it's mixed together with those nutrients and everything that's coming up from the surface, to the surface, sorry. Okay, yeah, it's about 140 degrees Fahrenheit down there. So it's hot, but it's not too hot for these shrimp to survive. And near this location, there's another hydrothermal vent location that's a lot deeper and a lot hotter. It's called the Mariana Back Arc. And that might sound a little familiar because of the Mariana Trench, which is the deepest part of the ocean. We'll dive down here, not all the way down to 5,000 meters, but about 3,000, so 1.86 miles, which is still pretty deep. And here we see some crabs. You can see the water is kind of shimmering because it's so hot and there's all these nutrients moving around. A couple crabs, a couple of shrimp, but not as many as we saw at the last vent location. And then we can see here, if I zoom in, at this location, we have these snails, little swirly thing there. So the snails are about this big. We have a 3D model of one of the snails here. And this is what they look like when they're a little bit larger, blown up. So scientists are very, very creative people. So they saw all of these snails at this vent location that they might not have seen at other vents. Any guesses as to what they named this vent location? Any guesses?
Not seeing anything come into the chat yet. If you guys want to, you can leave your responses in the chat. Well, there we go. Somebody says shrimp vent.
Yes, they actually, no, they named it snail actually. Not shrimp. This one doesn't have any shrimp, but we have the snail vent. So yes, along the same lines. They saw all these snails, the vent is called snail. And then another example of the scientists' great naming capabilities is at a nearby location. So let's take a zoom. Let it run for a minute. Okay, so this location is called a black smoker, and we wouldn't be able to see any of this black smoker stuff or any of these animals without the light from the submersible, because like we said, it's all dark down there, so these organisms have never seen light before. But within these black smokers, so you can see the shrimp on the outside, but within them are these microorganisms called archaea. And they're like bacteria, but they can withstand even harsher, more extreme conditions. So, given that they found archaea in these vents, what do you think they named this vent, this black smoker location? Don't think too hard about it.
Yeah, and somebody says,
yeah.
Yep.
Black smoke vent, that's a good guess, but yeah, they named it archaea. So archaea, but with an N. Yep. So the animals that you see on this data set are supported by the food web that depends on these archaea and these single-cell organisms and these bacteria that take the chemicals that are expelled by these hydrothermal vents, and they convert those chemicals and nutrients into energy. So like the photosynthesis, the plants that do photosynthesis, they convert sunlight to energy. These bacteria and archaea, they do chemosynthesis. They take chemicals and they turn them into energy. And they're the basis for this whole food web down at these hydrothermal vents. All right, so far today we have explored 3 different hydrothermal vent systems, and they all have these similar but slightly different organisms, right? Different systems going on. But they all depend on these chemosynthetic bacteria without sunlight, right? So let's pull up one last data set. So in this data set, we're looking at the age of the seafloor. We have these red areas where the seafloor is very new, and these blue or purple areas, as it turns around, that we'll see where the seafloor is older. So these red areas, there's a lot of them along these plate boundaries. So there's always new seafloor being created. So if you're interested in science or just keeping up with some new discoveries, this is a really, really good field to look at, because there's always new vents being created, and we're always discovering these new vents. Always something new. All right, so do we have any questions about anything that we've seen so far? We're reaching the end of our program, but we will have a short craft in a minute, and we can pull up any data sets that you want to see that are even not related to this program. Nothing.
Nope, doesn't look like we have any questions so far.
Okay, that's okay. If anybody thinks of any, you can let us know. The sphere is a 6-foot diameter, just gray ball with paint on it, and it's hanging from the ceiling. It's not actually rotating, it just looks like that because of how the projectors and the technology works. So it's super cool. We can bring up different planets. We can bring up stuff about animals, migrations, about people, all that sort of stuff. But if you want to hang out, we can do our craft real quick. When you signed up for this webinar, should have mentioned that you would, if you want to do the craft, you could get a straw, a pipe cleaner, and maybe a feather, and we can make our very own riftium-worms. So, let me get my materials here. Start with our pipe cleaner and our feather, and we're just going to wrap the pipe cleaner around the feather really tightly. A blue feather this time. So it's like those red plumes, but it's a blue feather, right? Super easy. And then we're just going to pull our paper straw that we have and put the pipe cleaner into the paper straw. And now we have a riftia worm in Decker at the outside. But something that's really cool about these riftia worms is that they have this ability to kind of pull themselves into their tube. So pull that plume inside. So you can do the same thing with our pipe cleaner worm here. Cool. Cool. All right. Still no questions or requests?
I haven't seen any roll in yet. Alena, would you be able to show us a planet that we could pull up on the sphere?
Yes. Let's pull up a planet. Pull up our favorite planet. Yeah.
Ooh, and we have a request for Pluto and a question that came in, which is perfect.
Question.
So the question asks, how far has life been found away from the vents?
That's a really good question. I don't actually know the answer to that. I will say that there's been some studies about how the vents are connected through different like species dispersals. So how there are some organisms in between these vents. And then it's also just, there are lots of deep sea organisms that we have found that we're still discovering. There's things like octopi and squid and various fish that live down very deep. But I'm not sure how far they live away from the vents. That's a good question.
Yeah, no, then you can kind of think about the bottom of the ocean with these hydrothermal vents almost like little cities for animals. And so there's other locations that can happen too, like when a whale dies, for instance, something happens called whale fall, where it goes to the bottom of the ocean and then all these animals just gather around this whale and it's like a huge party. But then the rest of the bottom of the floor is like just, you know, like going out to the suburbs or to the rural areas where there's just little areas of life all around, but mostly it's just kind of vast and empty. So there's areas with high concentration, and then as it goes out from there, it kind of gets lower and lower concentration.
Yep. We have brought up Pluto. Our Pluto data set is kind of interesting. So we get these planets from NASA, the images from NASA and NOAA, and we only have an image of half of Pluto because that's the way, you know, snapped it as the satellite went by. So it looks like a gray blob on this side, but up on this side. I think there's one really cool one that I like. It's an exoplanet planet. Where is it? Yes, okay. Kepler 10b, this is called Kepler 10b. And it's like lava on one side and not on the other. Like it's still hot, but I like how it has, you know, one side that's so much closer to this heat source. Any more requests? All right. If there aren't any more requests or questions, then we can wrap up our program for the day. And I hope you all enjoy it and you learn something new about these hydrothermal vents and they're really cool organisms. The largest animal that has been found around the vents. The riftia worms are pretty large. They're like, I think 3 to 5 feet long. Not sure how, there are some very large organisms down there, but I think the riftia worms are probably the biggest ones they found on the vents because the shrimp are pretty small. And most of the, you know, the primary producers are those microorganisms. Do giant squid live there? I know this answer. Nick, do the giant squid live at the hydrothermal vents? I don't think they live at the hydrothermal vents.
No, this is the
deep down.
question. So
Yeah.
giant squid do live at the bottom of the ocean, but the bottom of the ocean is basically just like how the surface of the earth works, right? Where there's mountains and ridges and stuff. So the hydrothermal vents are like the underwater volcanoes, and the giant squid would live in basically like underwater valleys or underwater prairies almost that are all the way down at the bottom. They live super far down, but it's a different area. So it's going to be different types of animals living there. So if you think about it, it's really hot water coming up, so the squid would get cooked if it lived right next to the vents. All the animals that live right there are all super specialized to live there.
Yes, they are.
Great question, though.
Cool. Well, I hope you guys have a great rest of your day.
Yeah, thank you guys so much for tuning in.